Welcome students. Let us see an interesting question from the chapter complex number. Question is related with conjugate of a complex number. Here question is for all Z1 and Z2, these are Z1, Z2 are complex numbers. For all Z1 and Z2 belonging to set of complex numbers C, prove that first part conjugate of Z1 plus Z2 is equal to conjugate of Z1 plus conjugate of Z2. And second part of this question, conjugate of Z1 minus Z2 is equal to conjugate of Z1 minus conjugate of Z2. We have already discussed in the previous videos that what is a conjugate of a complex number. Let us make it clear. If Z is any complex number a plus ib, then its conjugate is denoted by Z bar, and this is equal to a minus ib. Simply by changing the sign of imaginary part, we get conjugate of a complex numbers. So let us see the solution here. Start with first question. This is to prove that conjugate of Z1 plus Z2 is equal to conjugate of Z1 plus conjugate of Z2. Let us suppose that Z1 is a complex number A1 plus IB1 and Z2 is another complex number A2 plus IB2. Correct? So therefore Z1 plus Z2, this is equal to A1 plus IB1 and plus A2 plus IB2, and this is equal to, we will make group of real numbers A1 plus A2 here. This is A1 plus A2 plus imaginary part is I into B1 plus B2. Correct? This is the value for Z1 plus Z2. Now taking conjugate. Therefore, conjugate of Z1 plus Z2, and Z1 plus Z2 is this much. So A1 plus A2 plus I B1 plus B2. This conjugate, and here conjugate means simply changing the sign of imaginary part. So this will be equal to A1 plus A2 minus I B1 plus B2, and this can also be written as A1 minus IB1 minus IB1 is here, and A2 minus IB2. A2 minus IB2, and this is nothing but conjugate of Z1 and plus this is conjugate of Z2. So it has been proved here that conjugate of Z1 plus Z2 is equal to conjugate of Z1 plus conjugate of Z2. So first part has been proved. Similarly, we can prove second part also. So also Z1 minus Z2 whole bar means conjugate is equal to Z1 minus Z2. We have to put negative sign here. So Z1 is A1 plus IB1, this minus sign. Z2 is A2 plus IB2. A2 plus IB2. At the initial stage, let us don't write this conjugate. Simply we are writing Z1 minus Z2. So Z1 minus Z2 is equal to this much. And this can also be written collecting real part in one group. So this is A1 minus A2. A1 is here, minus A2 is here. And we will now take I common from these two terms. So plus I B1 minus B2. Correct? And therefore, conjugate of Z1 minus Z2, this whole bar, is equal to Z1 minus Z2 is this much. So conjugate of this much. So this is A1 minus A2 plus I B1 minus B2. This conjugate. So this sign will be changed. This will be minus here. So this is A1 minus A2 minus I B1 minus B2. And this is equal to A1 minus I B1, A1 minus I B1, and minus A2 is here. So minus will be here, minus A2, and here minus I into B2 is plus I B2, but minus sign is here. So A2 minus I B2, and you see this is conjugate of Z1. Z1 is given here, A1 plus I B1. So its conjugate will be A1 minus I B1. So here we can write this is Z1 bar and minus this is Z2 bar, conjugate of this complex number, conjugate of Z2. So minus Z2 bar. So you see here we are proving that Z1 minus Z2 whole bar means conjugate is equal to Z1 bar minus Z2 bar. So second part has also been proved here. This is very interesting and important question. Hope you have understood it. Remain in touch with these videos. We have to see some more important questions. And please share this video with your friends also. Wish you all the best.